third time, see if I can get the last two problems in before someone else comes to my door. All right, so number 20. Number 20, there's two lines intersecting. They're creating two vertical pairs. This is a pair of vertical angles. This is one pair of vertical angles. This is another pair of vertical angles. So I know these are congruent and these are congruent. So I need to find the value of x and y. So I know that this is a linear pair. They're adjacent angles and their non-shared side forms a line. So I know this angle plus this angle equals 180. Problem is that doesn't help me because I have two variables in that expression. Here, this is also a linear pair. But now, so I know this angle plus this angle, they share this side. Their non-shared side is a line, so they're a linear pair, so I know they're equal to 180, and they both only have one variable in that expression. So now I can add those expressions and set them equal to 180 and solve for y. So I'm going to be able to find y here. So I'm combining like terms and I'm isolating the variable. So now I know that y equals 2. So back up here, let me get out some of this clutter. So here we said these two lines create two pairs of vertical angles. So this angle and this angle, vertical angles, they're congruent. So I can set their expressions equal to one another, but this one has an xy and this one has a y. Now I know what y is though, so now I can plug in for y. So I can write the equation 3x minus 2 times 2, because that's the value of y, equals 14 times 2 plus 12. So 3x minus 4 equals 28 plus 12. Simplifying. Oops, forgot to bring down my minus 4. Just going to add 4 to both sides. 3x equals 44. So now I know that x equals 44 thirds. And number 21 is a proof. Let me see. Alright, I think I'm gonna. Okay. So 21 is what we're working on now. The given is that AB equals 50. So I know that this whole thing equals 50. And they want me to prove that x equals 8. So that's what they have in the last statement. They've already plugged in the given. Now they tell me that AC plus CB equals AB. AC plus CB equals AB. I know that's true because we learned about the segment addition postulate. Now they've plugged in expressions here for the length of AC, the length of BC, and the length of AC. So that's going to be the substitution property of equality, but I'm just going to write substitution property. Now we're distributing here and rewriting, so that's the distributive property. So remember, you're always looking, how do we get from this statement to this statement? How we got there was a distributive property, right? So the reason for the two previous statements. So now we're looking, what is the reason or what we've learned that we could prove, we can go from this statement to this statement. So This is the one where everybody likes to write combine like terms, but really that means substitute, right? We're substituting 2x plus 4x with an equivalent value 6x. We're substituting negative 2 plus positive 4 for plus 2, so that's the substitution property. And now we had to subtract 2 from both sides to get from 6x plus 2 equals 50 to 6x equals 80, so that's the subtraction property of equality. And now we're dividing both sides by 6. That is the division property of equality. All of these are of equality. I don't really care if you write this part, unless we're talking about transitive. If we're talking about transitive, you have to tell me if it's the transitive property of equality or the transitive property of congruence. Phew, I made it through.